Hey, and welcome back. And this is called Symmetric Tree. It's question 101, and it's an easy level tree question. So, yes, let's get to it. So, for this question, we're given a tree, and we want to see if they're symmetric. And so, symmetric means that it's like they're mirroring each other. So, we always know that, okay, if you have a root, you don't really have to compare it with anything here. But then, when these branch out, so we want to compare that the left node here is the same as the right node. And in this case, this is like one little thing you have to remember is that you want to compare on the left branch, I would say this left subtree, you want to compare its right children with the right subtree's left children. So you kind of see that they're swapped here. And so although this is its left, you want to compare it with the right subtree's right. So yeah, I hope that kind of explained things. You might have to pause and rewatch it, but it kind of switches in this case. That it's because they're mirroring which ones you want to compare with. So it's good to keep that in mind. So now one thing that you want to think of when dealing with these questions is often how can I do this recursively? For a lot of these tree problems, you can do it just as performant in a recursive manner, but it's a lot less lines of code. And once you kind of do enough recursive tree problems, it's really easy to implement them, and it kind of saves you some time too to make sure that you get it right and can explain the whole process of it and the time complexity. So I highly suggest it. So we're going to solve it recursively. So let's get to it. So what we're going to do is we're going to return, and we'll just call this method check, and we're just going to pass its right and left node. And so this method doesn't exist yet, and we're going to implement it. The reason why we want to create a separate method, and I'll just fill out the rest of its parameters here, is because we want to have a method signature that has two parameters. And because we're given a method that has just one parameter, we need to kind of put all the work in a separate method. So yeah, it's going to have, it'll be a private method since we're just calling it in this public method, and it'll be returning a Boolean, and we'll just call it check. And then in its parameters, we'll just have two tree nodes, which will represent the left and right nodes. So we'll call this left node and right node. Okay, so what we're going to do here is I think we'll have kind of three sections of checks. The first one is we want to make sure that anywheres where this is null, it should be null on the mirroring side or the opposite side. So if the left node is null, naturally we should expect the other one to be null. And if so, we want to return true. Now, if it gets past this point, then we know, okay, they're not both null, but we still want to check if one of them is null. So if the left node is null or the right node's null, we want to return false. And so this is just checking, okay, if this left subtree has a null node, but in the mirroring side at that same location, it's not null, then clearly they're not identical, they're not symmetric, because one has a node in a spot where the other one doesn't on the opposite side. So we want to return false in that case. And then finally, we're going to have just one last line of code. It's only 3 lines in this method here. And so we want to return, we first want to check if the values are equivalent. So in this node, this value should be equal to the other. So because we know that they're not null, because none of them will be null if it gets past these two checks, then we can check for the value without getting an error. And we want to verify that the values are equivalent. And then next, we're going to call this method twice. And this is why it's a recursive approach. And so this is going to take just some knowledge or understanding of how the tree works, and that little trick that I mentioned before where, okay, you want to compare the left tree's left nodes with the right tree's right nodes, and the left tree's right nodes with the right tree's left nodes, so they're reversed, and that's because they're mirrored. So in that case, we want to return and recurse on the left node's left value and then the right node's right node. And then we want to do the exact same thing but the opposite for the next check, where we want to do the left node, compare the left node's right node with the, so I guess I kind of want to say this tree, so the left tree's right node with the right tree's left node. So let's go ahead and run that. Oh, there's just a small error. We need a semicolon. True, try submitting, and success. So yeah, let's just take another little peek at it. So essentially we want to pass all of our work into a separate method because we needed two method parameters for the left and right trees. And then we want to evaluate, okay, wherever the left tree has a null node or a non-existent node, and where the right tree has a non-existent node, that means that that's true in that case. The next case we want to check is, okay, wherever this has a node, the other one should have a node. Otherwise they're false. So checks that case. We want to verify that the current node on the left tree and the current node on the right tree have equal values. And then simply we'll recurse on them using that little trick there where we want to compare the mirroring nodes on those two trees. So I hope that helped, and good luck with the rest of your algorithms. Thank you.